Hello everyone. Today we're going to continue using Laplace transform for circuit analysis, and this time, as we discussed in class, we're going to actually implement Laplace transform at the level of writing equations for components. And in other words, we will no longer see any equations in the time domain. As a reminder, I already have written the equations for inductor and capacitor in the Laplace domain down here. And when we start writing the equations for the circuit, we're going to use these two equations as a guideline to write our equations for components. With that, let's start the analysis. So in the circuit, the switch has been in position A for a long time, and what that means is that all the way to t equals to 0 there has been no independent source of energy connected to the circuit, and therefore we can conclude that the capacitor, there's basically no voltage and current in the circuit, including for the capacitor. Now for the inductor, since the switch has been in this situation for a long time, we can treat the inductor like a short circuit, and therefore this part of the circuit that is on the left is basically simply a power supply that is connected to a 3 ohm resistor. Now I can quickly redraw that circuit down here. Let's do that. This is our power supply, and notice that the positive terminal is at the bottom and the negative terminal is top. Now this is where our inductor used to be. And now if I want to call this terminal, or down here, call it my ground, which I'm going to try here, and this is 24 volts. Now this up here immediately, therefore, is going to be minus 24 volts. So notice again, it's the voltage of this terminal minus the voltage of that terminal that equal to this number right here, and this is 3 ohm. Now if we want to assume that the current in this circuit is going in this direction, and I'm going to call that IL0, this current obviously is the same. It would be minus 24 minus 0 divided by 3, so IL0 minus is minus 24 divided by 3, which is minus 8 amps. So with that realization, now we can move on to t equal to 0 and above. Once the switch moves position from A to B, at this point this part of the circuit is completely disconnected, and we can redraw the circuit quickly. Let me actually do that too. So let me remove this part of the circuit. From t equal to 0 and on, this is our circuit. Okay, so let's move on to writing to basically starting our algorithm. So we're going to move on to labeling the circuit. There's one node. This is the second node and third node. So if this is my ground, I'm going to call that V out, since this label is already given. This is the plus and minus signs of V out, therefore this voltage minus this voltage is V out, and this is assumed to be 0, so this automatically becomes V out. And notice that I'm using capital letters to indicate that these are all in Laplace domain, and therefore everything is a function of S. Okay, so the current that's I'm going to label for this, I'm going to assume that the current is the same as what I had assumed for calculation of the initial current. So this is IL. I'm going to call this I1. This would be IC. And this current is actually I phi, so we do that. The current passing through the dependent power supply, I'm going to call that I2. So make sure that we're going to have a current for all the components in the circuit. With that, we're done with our labeling. Now we're going to move on to writing equations. So there are two nodes for which we can write KCL. So KCL IL, I1 and I2, all three of them are leaving that node, so they add up and become equal to 0. So IL plus I1 plus I2 is equal to 0. For the other node, I2 is going into this node, and IC and I phi are leaving, therefore I2 is equal to IC plus I phi. Now from these two I can immediately conclude that IL plus I1 is plus, and instead of I2 I'm going to use this equation, so plus IC plus I phi is equal to 0. Now for those of you that are familiar with the concept of a supernode, you know that this is the equation that you would get as a result of using that technique, and I don't really see any necessity to use any of those techniques, because just following our algorithm is going to result in the same thing, and there's no trick or confusion. So we're just going to stick to this. Now we're going to move on to writing equations for components. There are 1, 2, 3, 4, 5 components, and therefore we're going to have to write 5 equations. For the inductor, this is the equation down here. This is the equation that we're going to use. So V out minus 0 is equal to L, which is 5.625 S. This is S. So I'm gonna have to make sure that I can differentiate between S and 5. Times IL S minus 5.625 times the initial current. Now the initial current, we know that was minus 8, so that's 8 times 8 with a negative sign, which means that this becomes a positive. Okay, so that's the equation for the inductor. Now moving on to the 5 ohm resistor, the current I1 is equal to V out minus 0 divided by 5. So that would be the equation for the resistor. For the capacitor, again, this is down here is the equation that we're going to use, but there is no initial condition, so that part is going to completely go away. So current IC is equal to C, which is 0.1 S times V1 minus 0, so that would be just simply V1. And there are 2 more equations that we need to write. For the 20 ohm, I phi is equal to V1 divided by 20, is V1 minus 0 divided by 20. And finally, for the dependent source, the equation is this: voltage of the positive terminal minus the voltage of the negative terminal is equal to 25 I phi. So that would be V out minus V1 is equal to 25 I phi. Okay, so with this we can start doing math. So by replacing this equation down here, I can write V out as a function of V1, or the other way around. So V out is equal to V1 plus 25 V1 divided by 20, which is simply 2.25 V1 so now I have V1 as a function of V out, and therefore I can write these 2 currents as a function of V out. This current right here was already a function of V out, and finally I can write IL as a function of V out using this equation. So let's just move things around here. So IL is equal to V out minus 8 times 5.625 is 45. Minus 45 divided by 5.625 s. Rewrite this to make sure we can again distinguish. This is s and not 5. Okay, so now I can write the equation up here all as a function of V out. So V out minus 45, that's IL, divided by 5.625 s plus I1, which is V out divided by 5, plus IC, which is 0.1 s, times V1, which is V out divided by 2.25. So let me just rewrite quickly. So V1 is equal to V out divided by 2.25. So I'm going to use that and put it in here. So that would be 0.1 s times V out divided by 2.25 plus I phi, which is same V out divided by 20, so that would be V1 divided by 20 times 2.25, and that again is actually 45. That's equal to 0. So from this I can multiply the whole equation by 45s and simplify the equation. So 45s times this is going to give us 8. So 8 times V out minus 8 times 45, which is 360, plus 45s times this becomes 9sv out, so that's 9sv out, plus here becomes 20s, that's 2s2 v out, plus SV, sorry, this has been V out, not V1. V out is equal to 0. So we're going to continue here. So from here, V out is equal to 360 divided by, so we have 2s2, 2s to the power of 2, and then 1s and 9s right here, that's 10s plus 10s. And finally, we have 8 V0 or V out here, so that would be 8 Okay, so this is V out as a function of S. Now, in order to calculate V out as a function of time, let's first simplify this. So this would be 180 divided by S2 plus 5S plus 4. So we first find the roots of this here, down here, and the roots, once you do that, you realize it's going to be 4 and 1, minus 4 and 1, so we just rewrite this as K1 divided by S plus 1 plus K2 over S plus 4. So then to calculate K1 and K2, there are all these different techniques that we have discussed. You can multiply by both sides by S1 plus 1 and then evaluate what's left of it at S minus 1, which means K1 becomes 180 divided by 3 or 60. So 60 divided by S plus 1, and you just do the same for S plus 4, multiply both sides by S plus 4 and evaluate this at S minus 4, which becomes 180 divided by minus 3, which is minus 60, so that would be minus 60 divided by S plus 4. Now, if we want to calculate V out t, we just take the inverse Laplace transform of this function, which you can easily figure out that it is 60 e to the minus t minus 60 e to the minus 4t, and the whole thing obviously is multiplied by ut, since everything started at t equal to 0 volts. Hopefully this has been helpful. This concludes our analysis.